paper. Okay.
Sir, one more doubt I had.
Hmm.
Uh, will there be any Hindi sessions? I mean, regarding solving of these?
In Hindi language,
Yeah, yeah.
I can do, but just give me a vote. How many of you don't understand Hindi? Just give me a thumbs up. How many of you understand Hindi? Now give a thumbs up. What about others?
Sir, I don't understand.
Actually, I don't know how many of you understand Hindi because you are not responding.
I think, sir, it is okay if you can speak English, we can understand. Not problem at all.
Okay,
Okay, sir.
okay. This session will not be in Hindi. Okay. Uh, okay. So give me just Endterm paper. Anything. Otherwise, I'll just take from my side. If you have already one paper for Endterm, you can just give a link in the chat so that I can start discussing that. Anyone of you.
One thing I want to say, sir. Actually, can you discuss how to use Gaussian elimination for solving x is equal to
Yeah.
b?
Yes. So
One example I want to know, sir.
definitely there will be some questions on Gaussian elimination because this is uh, there must be some questions. So we will discuss that. Okay.
Okay.
Yeah. So just anyone solve the give me a link of the question paper.
Sir, actually, I've solved one from the eighth grade, and that was the 2023 paper.
Hey, you just give me any paper, okay? Any interim paper, we will solve that. Any one of you,
Um,
just give it in the chat. I will discuss that.
sure, sure, sir, sure.
Yeah, so just all of you, just to make sure, are you able to see this question paper?
Yes, sir.
Yes, sir.
Okay, so
If only
link
if I,
uh, link is in the chat. Open this exam paper in your tab as well, okay? Because I'm sharing my entire screen, so maybe if I'm changing my screen, still you should able to see the question paper in your computer. Okay,
Yeah.
link is in the chat. Okay, so this is the first question. This is Endterm paper, right? Endterm. There are 15 questions here. It should be Endterm.
Yes, sir. It is Anthem.
Okay.
2023.
Okay, no problem. So all of you, this is the first question. A matrix is given. Okay. Then what is the value of trace of A? Where trace of A denotes the trace of A sum of the diagonal entries. Okay. Uh, yes. Yeah, solve this question number one, all of you. After some time, I will discuss. Okay, so everyone are getting the idea how to solve this. Anyone who is
Yes,
not
sir.
okay, you are solving, then solve. If there is anyone who is not getting how to solve this, I just tell me. I will give you a hint. Okay, then solve and give me the answer. Okay, answer. I should hide the answer.
Can you just share the screen?
Yeah, okay, I'm sharing. So I'm just telling. When the first person give me the answer, after 1 minute of that, I will discuss. Okay, this is how I will give you time for solving. At least one should be able to will do the question. Okay.
Yes, sir, I got three.
The three is going to be the answer.
A is equal to 1, D is equal to 1, C is equal to 0, B is equal to 1.
Actually, I've got D. C is equals to 0.
D and C is equal to 0. Uh,
Okay. So what is the process you have used? I mean, uh, just
So,
you can quickly share.
so first of all, I equated the
uh,
matrix and I've got the value of
yes, sir.
like
Yeah.
A, B, C, and D, and
Yeah.
then I just found the trace.
Yeah. Basically, because these two matrices are same, so A plus B, and this would equals to A plus one, right? And because this entry should be equal to this one, we will get a equation B plus C equals to one. This is the equation.
Yes, sir.
And second, when you compare these entry, you'll get B plus C minus D equals to 2C minus 3D plus 3. Okay. So from here, what is the equation we get? This is the C, both side. Okay. So we'll take everything in the left hand side. So we get B, okay, minus C plus 2D equals to 3. Okay, this is the second equation. And similarly, these two more equations. And so this is how we'll have four equations. Okay. and so we'll get the value of a, b, and c, d, and then we can just add these two. Okay, this is trace. Is this process right? Whoever got the correct answer.
Yes, sir. I created and I get A
Okay,
is equal to 1, D is equal to 1, C is equal to 0, and B is equal to 1.
okay, okay. So anyone who have doubt in this question, just tell me. Otherwise, I'll move on to the next question. Okay. So meanwhile, next question is this, and if anyone has doubt in the previous question, just tell me. Meanwhile, solve this question. And this is
So can you
uh,
please show the first question?
which question?
It's the first question. Okay, sir.
Yeah,
So
this one.
what is the answer? Three.
Answer is three.
Okay, sir. Thank you, sir.
Okay. Anyone has doubt, just tell me. I will solve completely. Okay. Otherwise, it will be waste of time. That's why I'm skipping. Okay. Solve this question. So this is 42 to 44. So this is the passage. Okay. Read this out and then I'll move on to the question. I think, uh, yeah, these are the questions. Anyways, just open this exam paper in your computer as well. The link is in the chat. Okay. Here. I'm sharing it again. Okay. Somebody joined late. Okay. This is the link of the question paper. Okay. So question says this is the beta. Uh, so clearly, this is a linear transformation which is taking a matrix and giving a vector. Okay, in R2, and it is taking a matrix in 2 by 2 matrix. Okay, so M 2 cross 2 basically. And so what you have to do, you have to find the matrix A, which is the linear transformation matrix. And when you find this A, then you will be able to give answers to which of the following matrix is A. Okay, and then okay, so just first find the A. Okay, take time and find A and give me the answer.
Sir, I get a matrix.
Okay, you got the matrix. Just after 1 minute, I
1,
will
4,
tell.
2 minus 10.
Okay, okay, no problem. After 1 minute, I will solve this question for all of you. So, anyone want more time? Anyone just raise your hand who want more time? Okay, so I'm just assuming that everyone have given a attempt. Okay, so how many of you got the answer?
Yes,
Yes,
sir.
sir, I get a
41.
matrix.
Okay, okay. Let me download this paper and open it in the Edge so that I don't have to copy paste. Sorry, take the screenshot. Okay, these are the first question. This is the second question. Yes. So here, okay, let me see that I'm audible. Yes. Okay, no, this is whoever asking for the link of the question paper. Okay, I'm pasting it again. This is the link of the question paper. We are solving question number 2. Paragraph based first question. Okay. So for this, how to calculate how to find the matrix basically. For that, we take the suppose this vector. Okay, the domain vector. I mean here it is the matrix, so we take 1 0 0 0, and according to this definition we'll find the value. So which is 1 0, so it will be 1 comma 4. Okay, and similarly we'll find t of this as well, which is 0 0 0 2, which is uh, 0 2, right? So 0 2 means 2 comma and 2 minus 10, right? Now what we have to do, we have to represent this vector in terms of the code basis of the codomain. Okay, remember this is very important what I'm telling you further. We now we will represent this vector in terms of at the as the linear combination of the vectors in the codomain basis. Okay, what is the
Yes, sir.
codomain basis? What is the codomain basis?
1001.
uh, it is given
Standard order.
standard order basis. That's why, because it is given standard order basis, so actually standard order basis don't make any change
Change.
in the coefficient. Okay,
Yes, sir.
so this is the property. That's why these values are same, otherwise this coefficient would be changed. We take these coefficients. Okay, and now similarly this is also can be
Yes,
written
sir.
as 1 0 minus 10 times 0 1. Okay, so we will take these coefficients only, but because these coefficients are same as these, can you tell me why these are same? Only because of standard order basis for the
Standard
codomain.
basis.
That's all. Okay, otherwise the coefficient would be different. So now these are the coefficients, so we can write first coefficient, second coefficient. Okay, and then 2 and minus 10. This is a. Okay, anyone, any doubt?
No, sir.
Sir, I did not get. Could you please repeat again?
Okay, What I'm telling you, to find the linear transmission matrix, we take the domain entry, domain input, okay, and try to find the image of that. So because for domain we are taking beta, right, which is this, okay, this we are taking for domain. So we find the image of this, first this and then this. So first of इसका image क्या होगा? If we try to find the image for this 1000, it would be according to the definition this. This would be the image 14. Okay, and image of this second, this one is this. Okay, and now once we got the image vectors, we will represent those vector in terms of the basis of the codomain, basis of the codomain, which is R2. Okay, and the basis for R2 is taken as standard order basis. We know it is 10 and 01. Okay, this is codomain. Suppose we are taking this gamma. This is for codomain. So because when we represent this vector 10, 14 in terms of these vectors, we take the coefficient which is 1 and 4. Okay, and for this we are getting 2 minus 10. We take the coefficient which is 2 and minus 10. Okay, when we write this in terms of standard order basis, and so we represent this coefficient as the first column and the second column. This is A. Is that clear now?
Yes, it is.
Yes,
Okay.
sir.
Uh, so this is the matrix A, which is 1, 1, 4, 2 minus 10. Question number 2, which of the following options are true? Okay. So rank of T. What is the rank of T? How to find the rank of T?
Row echelon form.
Yes. So we take this matrix and reduce it. Okay. Take this matrix and reduce it uh, according to the R, E, F. Okay.
Sir,
So you
can
can
we
Also
simply
by finding
the
determinant
go or not?
rank
wait,
equals
wait,
to
wait,
2.
wait, 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 wait. Someone is speaking. Yes. Can we
Ma'am,
see?
can we check, sir, can we check if the determinant is zero or not?
That is also very good way because it is only 2 by 2 matrix, so we can directly check. Okay. So determinant is clearly minus 10 minus 8. This is not equal to 0
Non-zero.
basically. So the
Not
rank
equal
is,
to zero.
yeah, rank is 2 because it is a 2 by 2 matrix, so we can directly check the rank. Okay.
Right.
But if it is a 3 by 3 matrix, then if determinant is 0, then we are sure that that rank is not 3, but maybe it is 1, right? Maybe it is
Sir,
2, maybe it is
Yes, sir.
does
Yes, sir.
this method of finding the determinant only works for like 2 cross 2 matrix or both for 2 cross 2 and 3 cross 2 matrix?
okay. Okay, don't try to remember this, just try to understand the concept, what why we are doing this. So because what will happen if determinant is 0 for this, then one row would be 0, right? This is certain. But
Right, right.
yeah,
Got it.
but yeah,
Yeah,
so this is but suppose this is a 3 by 3 matrix, then maybe two rows are 0, still determinant will be 0. Then rank would be in when two rows are 0, then rank would be 1. When one row is
right,
0,
right,
when
right.
one row is 0, then rank would be 2. So we are not certain. That's
Which
why.
means that that generalization will not be true in every case, right?
Yes, yes.
Okay.
Or you
Right.
can see clearly, you can see both the rows cannot be 0 here. Why?
Yeah. Um,
They are
because
linearly
They are
independent.
linearly
Yeah,
independent.
they are linearly independent, or you can see that they are non-zero entries. So if we can subtract one from then one would remain non-zero, right?
right.
Yeah, they are non-zero entries, so both rows cannot be zero. Okay, so rank is 2. Then there exists an isomorphism from RT, range of T, to R. What about this option? Isomorphism means 1 1 and on to relationship.
Yes.
So what is 1 1? 1 1 means when the kernel is only 0, right?
Yes, sir.
What is kernel? Kernel is those set of
Logic
point,
tree.
those set of points in the domain which are mapping to 0 0. Okay, so What are the points when this will be 0 mapped to 0 0? This image vector will be 0 0. Then what about
A is 0, B 0. Zero matrix.
yeah, A is 0, B is 0. So basically, kernel is 0, right?
Yes.
Yes.
Yeah, so we can say that this is
Sir,
1 1. Yeah,
in order to find 1 1, we can check nullity is equal to 0, right? So that's also
yes,
one
yes,
way.
yes, yes, yeah. Nullity is 0. Yeah. Yeah, okay. And then next comes what is the so it is asking there exists an isomorphism from RT. What is RT? Range of T. Okay, range of T to R. No, not this. Okay, this may be isomorphism. It looks like isomorphism, but what about RT? RT means range of T. So we are getting these points. Okay, range is
Yes.
this point. And so first we find R of T to R. Okay. So clearly range is in R2, right?
Yes, sir.
Why? Because rank is 2.
Yes,
Rank
sir.
is 2. That
Yes,
means
sir. Yes, sir.
range is in R2. So R2 to R cannot be a 1 1, right? Cannot be 1 1.
Yes, sir. We
Yes, sir.
can't be.
Yeah, cannot be 1 1. Okay. Anyone any doubt in this second option? Why
No,
this is
sir.
not true? Yeah, okay. And nullity of T. Nullity of T is clearly we just found out nullity is 0, right?
Clearly, it is 0.
Yeah. Yeah. So it is 1. We just find
Sir,
out.
one doubt I had, like,
Yeah.
is the above function is like onto?
Onto this.
Yes, sir,
Yeah,
that.
this is onto. This is onto. See, there are only A B, right? There are only 2 points A B, and
Yes.
we are getting R2. Okay, so we
Right,
can say
right.
that this is R2 to R2.
Got it.
Okay. Oh, anyway, it is not asked in the question, so don't stress because uh, yeah, we can see that it is onto. Yes, clearly.
Okay.
Okay. Last option. Where you going? Yeah.
But T is isomorphism, sir.
Yes. Yes. Yeah.
Okay.
T is 1 1. T is 1 1.
Yeah, it is.
Yes, T is 1 1 because it is kernel is 0, nullity is 0. Okay. This question is independent, right? 44. 244. No, no. This is also dependent to this. 44. Question number 44. Let B be the matrix representation of T with respect to the ordered basis beta for the domain and the ordered basis this one, not the standard. Okay. This one for the codomain. Which of the following are true? So we are changing the basis for the codomain. Okay, and when we change the basis, whatever the linear transformation matrix we get for that transformation, that that matrix are similar. Okay, that we know this. Okay, so it is saying if we get this B matrix, it will be similar to A, right? Rest of the option you guys solve. Okay, why this is true? Just make sure that y rank of B is not one. Every question solve this. Take your time, think about it. First one is just clear.
Uh,
Yes.
rank is not equals to 1 because it is similar to A,
We
and
will
rank
discuss.
of A was 2.
We'll discuss. We'll discuss. Just take some time, at least 1 or 2 minutes, okay?
Yes, sir.
Just to think about it.
Sir,
Yes.
uh, can you tell me in order to do similarity question, if any one condition is failed, let's say trace does not equal to both of matrix,
Sorry,
then
I didn't
what?
get.
Uh, let's say we have two matrix A and B, and the trace of both matrix are not equal, but determinant is equal. Let's say, right of. So
Okay. Trace
then,
is not equal, but determinant is equal.
yes, yes. Then
Okay.
what will happen? They will be similar or not?
Similarity is not actually related to that. This is the property that determinants are same. These are the properties, but similarity is different. Similarity is like uh, this matrix, this P inverse A P should be equals to B, or we can say that AP equals to PB, and where P is some invertible matrix, some matrix which has determinant non-zero.
Okay,
Okay,
okay.
these are the condition. And when this is P1, suppose this is P2, some different invertible matrix, then we can say these A and B are equivalent.
Mhm.
Okay, these are the terms. And this similarity is narrower condition. Okay, I mean, if the two matrices are similar, they are equivalent as well. So from this statements, we can say that suppose we find out the determinant. Okay, determinant of both side, then we get what we get. This determinant of these two, then determinant will split, so determinant of A should be equals to determinant of B. So these are the properties, not the condition for similarity. Okay, I hope it is clear,
Yes,
right?
sir. Yes, sir.
Yes.
I get my matrix B.
Yeah, no need to find the matrix B here, but yes, I was actually about to ask you that you should find the matrix B, but in this question it is not required. Using the properties, we can check A is similar to B. Okay, rank of B is one, not because rank of A is two, and these are similar. Then ranks are also equal. So that's why this is incorrect. Nullity of B is zero. Yes, because A has the nullity zero, and A is not similar to B. Clearly wrong. So for this question, no need to find B, but I insist find B just for
Sir,
practice.
can you please show how to
Okay.
find?
Please, sir.
Yeah. Okay. I'll find B.
All right.
Okay. So
Sir,
for
one logic in my mind.
hmm,
You say A is similar to B because they form by changing the codomain basis, right?
yes, yes. Basically, they are changing the ordered
But
basis only. So
okay, okay.
because the mapping is same, mapping whatever the
Mhm.
property that mapping has, they are same. We are
Yes,
just
sir.
changing the representation. So that's why it comes. Okay.
Okay, okay.
And why do we do
Got you,
that?
sir.
Because in some cases we get these matrices, this linear transmission matrix, diagonal matrix. Okay, and when we get diagonal matrix, there is a really importance of diagonalization. When you study MLF, you will see. Okay.
Okay, sir.
Okay, so for finding B, we already have this A. Okay, so we have this value 1 4 and 2 minus 1 10. Okay, 1 4 and 2 minus 10. Okay, so previously we were writing these vectors in terms of the standard order basis for R2, because that was the code basis for code domain. But in this case, the code domain basis is different. It is this minus, so you have to write something like A times 1 minus 1 plus B times 1 comma 1. Okay, this thing. And here you write some C times 1 minus 1 plus d times 1 comma 1. Okay, so when you solve this, okay, you'll get two equation, which is a plus b equals to 1 for from first. Okay, a plus b equals to 1, and minus a plus b equals to 4. Okay, so when you add these two equations, we get 2b equals to 5 and b equals to 5 by 2. And when you put this b in the any of the equation, we'll get a something. Okay, find out. So similarly, we can get c and d. So matrix would be a, b, c, d. This is b. Is that clear?
Yes.
Okay.
Sir, why are we putting this equal to 1 comma 4 and like 2 comma minus 10? I don't
Oh,
get this point
okay.
actually.
Yeah. This is from here. We are taking this. This is the value for this t of 1000. This is 14, and t of second coordinate is 0002, which is here. This one. This one we are getting 2 minus 10. Okay, that's why.
Okay, okay. So by actually putting the value of like standard basis on this.
Yeah. So here, because codomain basis is standard basis, so we are getting directly these coordinates, these coefficients. Okay, which are making this coefficients basically make this matrix, right? For the codomain, and here the codomain is changed, change of basis. So that's why we have to find this coefficient a, b, and c, d. Okay. Suppose I mean what I'm telling you is this one minus one. If it is suppose standard basis 1001, it was in the previous, right, previous question, then we would write 10 and 01 here. Okay, so what will happen? 10 means a and 01 means b. We'll get a comma b, which is 1 4, right? So we are getting a is 1 and b is 4. So that's why when for a standard basis the coefficients are same basically. Should I move
Okay.
to the next question?
Okay.
Okay.
Excuse me, sir. Excuse me.
Yes, yes,
I have
yes.
one basic doubt. Why we are always writing that the coefficient as in column wise, not in row wise? I know they are writing,
Hmm.
but I couldn't get the point why we are writing as A, B, and C, D in this column wise. Why we can't write in the row?
Okay. So you can ask this question to yourself as well. Suppose we are writing uh, t of x. Okay, x is any vector. Okay, maybe R2, maybe R3, anything.
Yes, sir. Yes, sir.
And this matrix suppose b or a maybe in the previous case, so we write this a times x. That's why we call this transformation matrix, because
Yes, sir.
we can directly multiply this matrix before, and then we can get this. Okay, so the reason is hidden in this. Okay, this statements. So because we are taking ordered basis, okay, that's why we write as a column. Okay, if you change the order, then the matrix we can write, we'll be
Matrix
writing
will
as
be
row.
interchanged.
Yes.
Okay.
So
Okay.
Excuse me, sir.
yes,
Can we also say that A is similar to B just by saying that they are from same transformation?
yes, yes, yeah.
Okay, thanks.
This question, consider the subspace W. Okay, this is for 45 and 46. Two questions are based on this statement. We have given a subspace, okay, of R3. And can we say W is what is the dimension of W? What could be the? I mean, actual dimension could be anything. We have to
Two.
find that, but
Two,
it
two.
definitely cannot be three, right?
Yes, sir.
Why it cannot be three? Because one variable would be dependent here.
Yes, sir. Z can be written in XY form.
Yeah, yeah. Z can be or Y can be written in terms of X and Z. So one variable is dependent. So there are only two independent variable. So dimension for W is two. Okay, solve this question. Okay, solve these sub questions, and we'll discuss this.
Done, sir.
Okay, just one more minute. I will discuss. Oh, okay. Let's solve the first question, and then say for second question, I'll give you some more time. Okay. All of you are able to get this basis or not?
Yes, sir.
Yes, sir.
Okay. It's very simple for all who are not able to get any idea, because we know two independent variable, so we can take any of the two independent variables. Suppose we are taking x and y as independent. Okay, so x and y are independent, so we are writing t1 comma t2 because they are independent. Then what would be z?
Minus T1 plus T2.
Yes, minus t1 plus t2. Okay, so this is clearly so because there are t1 t2, so we can write we can take this as 1 0. Okay, so 1 0, then we get minus 1, right?
Yes, sir. Options, I think they people take a X as a dependent or something.
Okay, so in
Write X
option,
in form of Y and Z.
yeah, in option we can, so we just know this, there will be two vectors, right? And so the options are first, second, and fourth. So first, second, fourth option can be correct. So for that we will discuss first option and put this that satisfy this condition, which is true for and for the second option, if we try to satisfy the second vector, which is 0 1, then 0 1, then it would be 1 minus 0, it will be 1, not minus 1, huh? Okay, so that's why the second option is incorrect. Similarly the fourth one is it clear?
Yes.
Sir,
Yes, sir.
can't we
Yes,
take, sir,
yes, yes.
y equal to x plus z, can't we take
X plus,
and y equal to, I mean,
y equals to,
that z equal to, yeah, that y equal to x plus z.
y equal to x plus z. Yes, we can take this as well.
How to write that?
Yeah, yeah, we can do that. Y equal to x plus z. In that case, x and z are independent, right? So it
Yeah.
would be
Yes.
it would be t1, t2, okay,
Mm.
and y would be x plus z, right? So t1 plus t2.
Yeah.
This would be the vectors. Yes, this is also right.
How to,
Basically, two vectors would make the basis. Okay.
so how to proceed? I mean that from that.
Okay, so we are not proceeding in this way because what is basis, right? Basis means
One zero zero.
two independent vector. No, no,
Okay.
that is a standard basis.
Okay.
Basis means two independent vectors. I mean, for this case, I'm talking about, okay, specifically. Okay, basically two because dimension of W is two, so we can say two vectors in R2, R3. Okay, two vectors in R3 because this is subspace of R3 that are independent will span this. Okay,
Okay.
so so in this plane, basically in this plane, if we take two vectors which are independent, then that will span. So basically basis can be infinite, basis can be infinite sets.
Yes.
Okay, we just take different vectors which are independent in this plane, and then we get a new basis. So basically we get this general basis. Okay, so basis is t1 comma t2 belongs to any real number,
Okay.
basically. Okay, of this form. So this set is actually basis set where
Okay.
we put any value of t1 t2, any real value, we will get a basis. Okay,
Okay.
so for this question, it is asked of the option following option can form basis. So we have to check. Yeah, first one is making basis, second one is not, and fourth one is not, and third one is clearly wrong because three vectors cannot make basis for this case.
So,
Okay.
sir, justify how the answer is A1 with that, yeah, with
Yeah.
that T1, T2,
See,
T1 plus.
see, see this option. Try to see. So
See,
you are saying T1 and T2, right?
yeah, T1 plus T2.
If you add, you will get -1, not +1. That's why this is wrong.
Oh,
Okay.
okay. Yeah, yeah,
Sir,
yeah.
if I try to solve from the question itself, I got 1 0 minus 1 0 1 1. But
Yeah.
but
Oh, oh,
I
oh,
can't
oh,
get the option.
okay. So you just find any set. Okay. So you are getting this one. So I found this one, and somebody found this one. Okay. Any set. Just take any set and just put the values according to the option. Suppose so in the second option you can see first vector is 1 1 0, right? So 1 1 0. So we will write 1 1. So T1 T2 is 1 1. Whether we are getting 0? Yes, we are
Yes.
getting 0. So that's why this vector is correct. Second vector 0 1. Put 0 1. 0 1. We are getting 0 minus 1, not +1. Okay.
Okay. So for that we have to get the standard form and then
0
we
1.
have to apply the from the
Zero
answer.
one. Sorry, 0 1. Let me correct myself. 0 1 we are getting 0
T2
1
minus T1 is 1.
1 minus 0, which is 1. Okay.
1.
And here it is -1. That's why this second option is incorrect. Okay.
Okay.
And
Okay.
you can verify this option according to this definition as well, because somebody took the y coordinate as dependent. Okay.
Mm.
So then still you have to take the values like T1 and T2. So suppose the first option 1 and 0. Okay. This
But we
1.
can't check like this x plus y plus z equal to 0. We can directly take it and we can't choose like
Sir,
that.
how can we find that basis? Okay, that is a verification, justification. Okay,
Hmm.
how to find that basis?
Which justification you are talking about? This is the basis set. Clearly, it
Checking,
is
checking.
written
Yeah, yeah, we are
T1,
checking.
T1, and we are not checking. We have found the basis set. T1 and T2 are any real number. We put any T1, T2, we'll get a basis. Okay. Bases are not constant. That if you find one basis and we get the exact same basis. Okay. Bases are infinite
I
sets.
think there people are quite confused. First, you can do, let's say we have a question in, so you just write X and Z or maybe Y in form of X and Z and take commons, you will find there is option match, right?
Okay.
So this is a
Yeah.
way that Lavanya ma'am
So
told us
okay.
once when.
Okay. I'll do that way. So any one of you, is that clear that this is also a basis set? Okay, where we
Yes,
are
sir,
taking
this is
where we
totally
are
clear.
taking y as dependent variable, or
Yes, sir.
this is also also a basis set. Okay, this is t1 t2 t2 minus. So here t1 t2 are any real number. This set is also a basis set. So there is no difference between these two. Everyone is clear with this?
Yes, sir.
This part. Okay, now just take anything, because we are agreeing with this that they both are same. So we are taking just one set. Suppose this one, this is the basis set, t1 comma t2 comma t2 minus t1. Okay, t1 and t2 are any real number. So we are taking this one. Okay, because both are same, you agreed in that. So now we are taking this one value, because t1 t2 are any real number, any real. So because they are any real number, we are taking 1 1. Okay. And we are getting 0. Okay. And second, we are taking -1 0. Okay. And the -1 0 we are getting 1. Okay. So we are getting this basis. Yes, this is true. And second time, for finding another basis. Okay, we are taking value 1 1 again. Okay, so there is already taken. Now we are taking 0 1. Okay, so in 0 1 we are taking what we are getting 0 1 1 0.
-1.
Okay, 0 1 we are taking 0 1. Okay, 0 1 t2 is 1 and 0,
Yes, sir.
but we are getting 1. Okay, and 1 is already there, 1 1 0. So this is another basis. This is also basis. This is also basis. Okay,
Yes, I got it.
but this option doesn't exist anywhere. Option exists this one, so which is not these are not equal. So that's why this is wrong. Okay.
Can we
Sir,
check
order
directly
can be
from the
changed
option
now.
that is
Yeah, yeah.
x
That is
plus?
actually that is basically you should able to understand the concept. That this is the most important thing. And for solving the question, it doesn't matter which way you are following for solving the question. This is not this doesn't matter.
Okay, okay, sir.
Okay. Thing that matter is which is are you able to understand the concept? What is basis? What is which vector we are taking independent? Why we are taking that independent? Can we take another variable as independent? Yes.
Yes.
So
Yes,
these
sir.
type of concepts are important. Okay.
Excuse me, sir.
Yes.
The answer ending 769, why not? That is the answer. That is the third option. 0 1 1 1 1 0 minus 1 0 1. This
Because
also is satisfying the condition. Na? X minus y plus z is
yes,
equal
yes.
to 0.
Yeah, yeah. But when you take the determinant using these three vectors, you will get zero. So determinant zero means these three vectors are dependent. But in order to form the basis, vector should be independent, right?
Oh,
Yeah,
okay.
that's why.
Okay, thank you.
Okay. And how do we know that determinant is zero without calculating the determinant?
One is a different vector of other.
Yeah, one is dependent variable here because you can see x minus y plus z equals to zero. That means only two of the variables can be independent. One would be, so suppose you know two of them. Suppose x and y. You already know z, right?
Yes, sir.
Yeah, that's why. Yeah, solve this one. This question. This is also dependent on that. If gamma is the orthonormal basis, okay. Now it is coming the concepts of week 7, I guess 7 or 8 maybe.
Yes.
So
Yes,
this is
sir.
also
Eight.
not, yeah, also normal basis. Gamma is also normal basis, and what is gamma? Um,
Gamma is
okay, we are
independent.
just taking anything. Gamma is
Yes.
also normal basis of W obtained from beta. Okay, this beta we already have.
Yes.
Okay, and from beta we are extracting a orthonormal basis, and then by using
Gamma is
gram
orthonormal basis by after gram is taken
obtained
process.
obtained from using gram Schmidt process from beta. So from beta we'll get the gamma, and now what we have to do process with respect to the usual inner product. Yes, usual dot product actually taken as the inner product here while calculating the orthonormal basis using gram Schmidt. And ABC is the projection of this vector onto W. Now projection is comes into picture. Okay, a lot of concepts are mixing in this question. Very important question. And then what is this? Okay, value of this. So basically you have to find the projection, okay, of this vector 1 0 1 onto W. How to find the projection? Remember the try to remember the formula. If you don't remember, see the formula. What is the I actually explained in one of the TA session. This is the vector, right? 1 0 1. So we have to find a projection of a vector onto a vector space, which is a subspace in this case, which is W. So I told you two methods: projection of a vector on a vector and projection of a vector on a subspace. Okay, so just see the formulas for that. How to find the projection of a vector on a subspace. Okay, you already know the subspace and orthonormal basis for that, which is gamma. Use that, finding the projection. And once you find the projection, you got the value of ABC in this. I will solve this question, but just to take your time and try to solve by yourself. Okay, I'm
Yes.
uh, I'm muting. All of you solve this and give me the answer.
Sir, can you just show me one more time beta? Can just one time.
Yeah. What are you asking?
Uh, beta. Can you basis vector? Actually, I didn't note it.
Basis
Just
vector.
scroll down.
Any vector you
Yes, sir.
can take. This one, 1 1 0 and -1 0 1. Any vector. This one.
Okay.
Okay, there is only one option correct. So yeah, take this one.
Okay, sir. Thanks.
Take this one. It is important. Take this beta only. 1 1 0 -1 0 1. I'm writing it here there. So this is beta or now. Right. Okay, I guess this concept. Actually, I want to solve this. So if anyone is trying and want more time, he can take. Otherwise, I will just help you.
You can solve, sir.
Sir, please solve.
Okay.
Yes, sir. I didn't even get it.
Okay. So, in gram Smith process, what we do? So first thing to note is, for sake of the solving of question in the exam. So in this question, it is asked only that we have to find the projection of this vector onto W. That's it. Okay, forget about the gram Smith process and all. So, for that sake, if we somehow get the projection of this vector onto W, the subspace, because we already have the basis, right? So we can find the projection of that the vector on the on this vector and on this vector, and we can add these two, and we'll get the projection of that vector onto this subspace. Okay, so whatever the projection we get, we have the value of ABC and we can get the answer. Okay, that is the different thing. For solving this question, we can see this usual inner product, which is dot product, and we have to obtain orthonormal basis. These two vectors, take the dot product, it is not zero, right?
Yes, sir.
Yeah, it is not zero. That means they are not perpendicular. These two vectors are not orthogonal. So because orthonormal basis means they should be
Yes,
orthogonal,
sir.
perpendicular, and I mean the inner product should be zero, and the magnitude or the norm of this vector should be 1. Okay, and norm is also for this norm is root 2, right? So norm is also not 1. So how to convert this using Gram-Schmidt process?
We'll divide it by its norm.
Yes, 1 1 0, we divide it by its norm, and this vector is now independent vector, so we can say this is w1. Okay, first vector we got. Now for second vector, what we do, we take this vector which is suppose u2. Okay, we are taking u2 and we are subtracting the projection of this u2 on. I am just solving this just to find this gamma. Okay, this is orthonormal basis, that's why we have to use this Gram-Schmidt process. Okay, so u2 minus projection of this vector onto basically we have to subtract the perpendicular component. Okay, or maybe a non the other component actually. We have to, there will be two component of this u2, right? In the direction of u1 or perpendicular to u1. So we will subtract that component which is in the direction of u1. Okay, u1 is this, basically the projection part. Okay, so how to take the how to take the projection of u2 on u1? Can you tell me the formula? Anyone? Projection of u2 onto u1.
The product of U and B divided by product of U and U upon multiply U.
And divided by
U and
Norm
U1.
U
Yes, norm U1. Yeah, very nice.
okay, this one.
W2, that is equal to W2.
Yeah, right, square.
Yes, is square.
Yeah, it should be square. Okay, so so this is basically this is b, we can say some x2. Okay, and when we divide this by its norm x2, we'll get w2, second vector. Okay, w2 would be x2 divided by norm of x2, basically the unit vector. This is our goal. So find x2 first, which is this. So how to find x2? We will write u2, which is minus 1 0 1 minus, and take the dot product of these two. Dot product is
Minus 1.
minus 1, right? So minus 1 times u1, which is, it will be plus 1, right? 1 1 0. Okay, and divided by norm of 2 square, which is 2, right? Is that clear, everyone? This part.
Sir, in that what are doing? U2, U1?
This is u2, this is u1.
Uh,
Okay.
-1 coming.
Okay, so this part is clear. We are projecting this u2 onto u1, and that component actually we are removing from u2. So only the perpendicular one will be remained. Okay.
Right, sir.
Yeah. So if calculations are correct, then this should be the answer. So then we'll get minus 1 when 1 by 2, which is minus 1 by 2, and minus 1 by 2, and okay, 0 plus 2
One
is
plus
1 by 2, and this is
one.
1
1.
1. Okay, this is 1. So this is okay. Now we divide this by the if it is not the unit vector, we'll divide the norm of this. So norm of this would be 1 by 4 plus 1 by 4 plus 1, which is 1 by 2, 1 by 2, 3 by 2 under root. So we have to divide by under root 3 by 2. So this would be w. Okay,
Right.
w2 w2. So we have w1. Okay, okay, we have w2. Basically we got these two vectors which are asked, which are gamma. Okay, now our task is to just find the projection of this vector 101 in the direction of w, sorry, in onto the subspace w. So how to do that? We take 101. Okay, take the inner product with
Sir, 3 by 4
1
square root will come to root 3 by 4.
root 3 by 4. This is 4. Why? It is 1 plus 1 by 2, right?
So,
3 by 2.
square norm is
I have
square root.
basically norm of this. What is the norm of this one? Minus 1 by 2, 1 by 2. It should be 1 by 4 plus 1 by 4 plus 1 under root, right? Which is root 3 by 2.
Oh, okay, okay, okay. Okay, sir. Sir.
Okay, now we are finding the projection of this vector, which is asked in the question, onto W. So W, for W we already have this gamma, which is the first vector is this, second vector is this. So we take this inner product with the first vector and multiply with this vector. Okay, so this is and plus. Okay, remember this plus. We take second vector, which is 1 0 1 comma. Second vector is, what is the second one? So here we can take 1 by 2 common. So we will get 1 by 2 divided by root 3 by root 2 times minus 1 1 and 1 by 2 common. So it would be 2, right? Yeah. So here we'll get what we get, root 2 divided by 2 times root 3. Basically 1 upon root 6. We can say 1 upon root 6 minus 1 1 2. Just confirm that whether we are getting okay 4 1 2, yes 6. This is the vector. So we get, okay, so this is the first projection. Okay, the on the first vector of the gamma, and projection on the second vector of gamma is 1 by root 6 minus 1 1 2. Okay, and multiply by 1 by root 6 minus 1 1 2. Okay, just solve this and find the first value, find the second value, and add them. You will get a some vector ABC. So all of you solve and just to verify that answer is coming. I mean, answer is, what is the value of ABC? And answer is 6 times of A plus B plus C. Okay. So all of you just solve this thing. Okay.
Sir, excuse me, sir. Can we take any vector as u1 and u2 in this both? So we will get the same answer.
Uh, Actually, while it is said that in this question, gamma is taken as the orthonormal basis. So, but W is same. So basically, if we somehow find the projection of this vector onto W, projection vector is same, right? I mean, so, suppose what I'm trying to say is, uh, this is suppose vector subspace. Okay, and we have this vector. Suppose this point. Okay, and we are projecting this on this. This is perpendicular, right? So
Yes.
it definitely be this point only. So this point will not change. Basically, we can take any basis on this, and we can find the projection on that. This point would be same, right? So yes, basically no need to find this gamma here. In this case, you can directly project on the beta. I will do that as well. Okay, you can directly, but calculation wise it will be tough. Here it is, once you find the gamma, the task is very simply, this is the projection, right?
Yes.
Yeah, so quickly just tell me, solve this, so this expression, all of you, and get me the value, this ABC. What is ABC? Vector. Meanwhile, I am also solving slowly. So this one, we can take root 2 outside. Okay, this is the property of inner product. So you have to just calculate the dot product of these two. So 1 1 0. So this is 1, and root 2 will be multiplied here. So we get 1 by 2. So, so first vector would be like 1 by 2, 1, 1, 0. Okay. Second one, we can take 1 by root 6 outside and get the dot product, which is 1, minus 1, minus 1, and 2. So 1, again 1, and root 6, 6. So 1 by 6. Second vector is 1 by 6 times minus 1, 1, 2. Okay. So when we add these two, then we get the value of this ABC. So which is okay. So 1 by 2 and 1 minus 1 by 6. 1 by 2 minus 1 by 6. We get 3, 2 by 6, which is 1 by 3. 1 by 3, comma 1 by 2 plus 1 by 6, which is 3, 4 by 6, 2 by 3, comma this is 2 by 6, that is 1 by 3, and 0, so 1 by 3. This would be ABC. So 6 times. So when we multiply by 6, we get, when we multiply by 6, 6 in this, multiply by 6, we get 2, okay, 4, and 2. Okay. So when we add these values, we'll get 8. Yeah, answer is correct. Everyone is try to understand this. The calculation is quite messy, but I hope you got the
Yes.
idea what
Yes,
I
we
have.
got.
Yes, sir.
Simply, if you divide this question into sections, uh, first part is try to find the grams orthonormal basis using Gram-Schmidt process. So this part is there. So you already know how to find the Gram-Schmidt process. We take these vectors u1 and u2, and then from u2 we subtract uh, the component which is on u1. Okay, basically the projection on u1. So we find the projection on u1 by this formula, and we subtract this. We get the second vector, and by making that unit vector, we divide it by its norm. So this is how we got these two vectors, which is w1 and w2. W1 is directly dividing by its norm, and w2, after getting x2, we divide it by its norm, and we get w2. Once we get these two vectors, w1 and w2, which are these vectors, this one and this one. Okay. Then we
So,
take
sir,
the
this is a
projects.
new formula for inner product, right? This formula that you write for
Yeah, this is
finding
yeah. Basically, this is the
this.
formula for projection. This one, this formula is for projection. Okay.
Mm,
But what happened when this u1, I mean that direction in which we are taking projection, if that is a orthonormal basis vector, that means a unit vector. Okay, then we don't
yes,
have
sir.
to divide by its norm. So that's what we have done here.
Okay, okay.
We are not dividing by its norm, directly taking the projection on the first basis vector of gamma, and then the second basis vector of gamma we are taking projection here, and we are calculating this, and we are adding this, and we are, because we have to find the value of 6 times a plus b plus c. When we multiply by 6, we are getting 2 4 2, which is it. Okay, just
Okay, sir.
take time, you'll able to do this. Now, very important thing, we will do, what we will do, we'll just quickly check one somebody asked that if we don't find this orthonormal basis, directly find the projection here of 101, whether the answer would be same. Let's check. From my point of view, it should be same, so let's check. 101, right? So 101 on this, so 101 with this 110 first vector, we are taking the projection, okay, in the direction of 110, dividing by its norm, which is root 2, Okay, this is the first vector. And when taking the second, sorry, norm is square, right? Am I right? Norm is square. Then it should be 2. Okay. Is that clear? Just some quickly someone confirm. This
Yes,
formula
sir.
is norm square, right? Yeah, that's what we are get. That's why we get the right answer. Okay. So this is, and second one is 101, and with the -101. Okay, -101. Okay, this is the vector only, and dividing by a norm square, which is 2. Here it is also 2. Okay. So what we are getting in the first, when you take the dot product, we get 1 uh, 0. So okay, 1 dot product of these two is 1, right? And for these two, dot product is -1, 0, and 1. So what is the dot product of these two?
First one is 1, second one is -1. The
-1,
top is
-1
minus,
or 0?
yeah, -1. No, -1.
1 and -1, -1.
Yeah, yeah, yeah,
Uh,
0, 0.
it is 0, right? So okay, this
Yes.
is actually easy. So this is 0, right? This projection is 0 basically. So only this projection basically. So which is, so this is 1, 0, and 0. So 1, 1 by 2, 1 by 2 times 1, 1, 0, right? This would come. And this is ABC. That means clearly this is not true, right? So there is some other concept. This is not true because this is not the projection. Projection is this. Projection is this one. Maybe some calculation mistake or what, I don't know. But projection is coming different way when we are, oh, okay, we are changing the basis, right? Here we are projecting on gamma. Now we are projecting on beta. Yeah. So on we are taking projection on different basis. That's why we are getting different answer. Okay. Is that clear? Someone who have doubt, the doubt is clear, right?
Yes, sir.
Yeah. Now solve this question. Based on the above data, answer the given sub questions.
Sir, can you give the formula for last problem? What is the formula?
This one,
Ah, yes, sir. That projection formula.
yeah, is that the projection formula? You
ABC.
can. This
Yeah,
is this
yeah.
is the this is the projection formula basically. This one. Okay.
Okay. ABC is a projection of 101 is telling you 101 onto W. So what is
Yeah.
W?
For a W, for W we got this basis gamma. Okay. So we are projecting this vector on the basis vectors of gamma. Okay. So basis vector, first basis vector is this. Okay.
Okay.
So we project on this, and then second vector is this.
Okay.
So we have taken both the projection on both vectors and added them. Okay. These are the final terms.
We are
This one.
projecting that vector to the all the elements of W.
Yes, 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 exactly. And then
Okay.
finally add them. And then we get one vector, which is the projection.
So set of okay. Thank you, sir.
Yes. So this is a comprehension question. This is a polynomial given to you, and question is number of critical points. Okay, now it is coming from the week 11, 10, or maybe something like that. Critical point you have to find out that. Okay, so all of you
Sir,
just,
in
yeah.
order to find critical point, let's say, uh, we need to tell x comma y as a single point, or x is equal to 0 and y is equal to 0 has a two critical point. Like in pairwise, we need to tell or alag alag.
So this is function in two variable, right? So for critical point, you have to do this fx equal to 0 and fy is equal to 0.
Yes, sir.
Okay. So fx is 4. What is your doubt actually? I mean, am I get it
Actually,
correct?
sir, I get after solving this I get a 3 point for x and 3 point for y. So
Hmm.
it's total six critical point, or I need to tell like in pairwise x comma y as a single created point.
No, no, no. There are six critical points. That's what is asked in the question. You have to find all the critical number of critical points. So if you are getting
Okay.
six critical points, you have to tell the distinct one. Okay.
Okay.
You're getting, suppose you're getting two critical point which are 1 comma 1, and from the other also 1 comma 1. So then the
Hmm.
critical point is 1 only, right? 1 comma 1.
Okay.
Okay. Suppose the solution for this equation x square minus 1 equal to 0. So sorry, x square
Hello, sir. Hello.
hmm.
Which paper solving you? Because I am just coming here.
Okay, this question try to find the
No,
all the
no.
critical. Yeah.
No, no, question no. Which paper is which PIQ paper solving?
Yeah, actually that I don't know, because somebody pasted in the chat. This is the link I am pasting again.
Oh, okay,
Okay,
okay. Link.
this is the link in the chat. Okay.
Okay, okay. Thank you, thank you. Continue, continue.
Okay, so critical points, uh, try to find this. And the next question is number of saddle points of f. So which of the following are the saddle points from those? Okay. Okay, this question. And then is there any other sub question? Number of local maxima for okay. Okay. All these questions are related. Number of local minima of fi. Okay. Again. Okay.
Only two.
50. Yeah. 47 to 50. Okay. So I'm just telling you the process. Okay.
Yes.
So this is fx, which is 0. Fy is fy is okay. We have to go. I think we have solved this question as far as I remember. 2 days back. I mean, in the
Yes.
second last session. 4y cube
Sir, I get
minus,
six critical point, but answer is nine.
okay, y, and here
Nine
y.
points.
This is 0, right? So these two are fine for everyone. These two.
Yes,
Yes,
sir.
yes, yes.
Okay. Now, how to solve this? We have to take x common from the first equation, and we'll get 4x square,
Sir,
or
four
maybe
you
4
can
or
take outside.
4 also we can take common. So x square plus
Three
3x uh, plus
plus two.
2. This is 0, right? So here we are getting x equals to 0.
X equal
Okay.
to minus two.
And this is the case 1, and second is this equation is 0. So what are the roots for this equation?
-2 and -1.
-2 and -1.
Yes.
Yes.
Okay. So these are the value of x is 0, -2, -1. Okay. Now when x is 0, we okay, there is no x in this second
Why
equation,
not
right?
2-1? 2-1 is also
Yeah, okay, that is also, this is case 1, this is case 2. Okay. So now when x is 0, we are getting these so there is no x in the second equation. 4y cube. Okay, there is no x. Okay, so when x is 0, we are getting we are putting x 0 in the second equation, but there is no x, so we just calculate this also. So for that we do y, 4y common, we get y square
Y
minus
square minus 4y.
4 not
No,
y,
minus 4 only. Minus 4 only. Yes.
minus 4. Okay, so here we get y equals to 0 and y equals to plus
plus or
minus
minus
2.
2.
Plus minus 2.
Plus minus
Okay,
2.
So basically 3 points from here 0 to -2, and here 3 points 0 -2 -1. So basically three options from. So we have to calculate this point x y, right? This is the critical point. So three options are available for this, and three options are available for this. Total 9 points. Is that clear? What I'm saying?
Okay, sir.
Yes.
Okay.
So you just take x as 0 and y as 0.
Yes,
This
sir.
is
Yes,
one
sir.
point. Then you take x as 0, y as +2. This is another point. Then take x as 0 and y as -2. This is 3 points. Again,
Okay.
same we will do for all 3 points. 0, -2, -1.
Yes,
You will
sir.
get
Got
9
it.
points.
Sir,
Yes.
what if, like in the second equation, which is 4y cube minus 16y,
Yeah,
there would be like there
these
was
three. These
any.
three. 0, -2, +2.
No, sir, I'm saying that let's say in the second equation there is x term. So what we'll
Hmm.
be doing, like taking the x value for the first equation and putting in the second equation.
Yes. Then we use these cases. This case like case one. Case one means x is 0. So for x 0, what are the points we are getting? Y, right?
Right,
So
right. Now got it.
yeah,
Thank you,
yeah.
sir.
Now because you have 9 points, so what you will do? You'll make this matrix f x x, okay, f x y. Yes, f x y. You will find the double derivative, okay? This double derivative, double partial derivative, f y x. So these two values will be same because this is polynomial, and polynomial are continuous functions. So then these terms and this term will be same. And here f y y. What is fxx? I mean, in general, what is ffx? This is
D square x by dx square.
okay. So del square f by this. So basically, you will differentiate this function with respect to x, and then again differentiate that with respect to x. So whatever you get, you put that here, okay. And now, so you will have some xy right there in the xy.
Yes, sir.
So you take just one coordinate, one critical point, suppose 0 0. So for 0 0, you will put those x and y value 0 0 in this matrix, and you will get some value, right? So for every critical point, you will make this matrix and then try to find the determinant of that. Okay, and compare with this. If determinant is 0, okay, then we say test is inconclusive. If determinant is negative, we say saddle point. Okay, somewhere it is asked saddle point. Yeah, saddle point for those points. Though for those critical points, this matrix giving negative determinant, that are saddle point. And for those points for that this matrix is giving positive determinant, there will be two category. Okay, so
Maxima and minima.
I'm writing here determinant of this Hessian matrix. If determinant is negative, we say saddle point. You already have 9 points, right?
Yes.
These are critical point. If determinant 0, then saddle point. If determinant of some force that is positive, then there will be two categories. If
Minimum
f
and maximum.
if xx is positive, then minima, and if
If x
xxx
is
is
negative,
negative, then
less.
maxima. Okay, so this is how you can solve all these questions. Okay, these are the questions. Now there is this question. From the list of terms, find out the best possible options for each of the given sub questions. Wow, okay. A critical point can be three best possible options. Enter only the serial numbers for those options in increasing order without adding any comma or space. Suppose answer is 7, 14, 17. You write 7, 14, 17. Okay. Yeah, solve all this question. Critical points can be, okay. What it can be critical points? Rank 2, Okay, a critical point can be ranked to. What is the rank of
No,
critical point? No, make no sense. Uh,
Yes.
zero,
no,
zero
null,
nullity, no sense, no
no.
sense, no sense. Which
No.
option makes sense?
Sir,
Global
Can be
map.
global, can be global maxima, right?
Yeah, yeah, it can be.
yes,
Yeah.
sir.
Can be saddle point. Can
Yes,
be global
Yes,
minima.
sir.
yes,
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 sir.
these make sense. Okay. And for this, an invertible matrix of order three has invertible
Nullity
matrix of order three.
zero
Invertible
deter.
nullity is zero, right?
nullity zero,
Nullity is zero. Non-zero determinant,
non-zero
yes,
determinant.
yes, yes. This is also true. And
Sir, why not option 14 is correct for the first question? Directional derivative exists in the direction.
for critical point, no. For critical point, directional derivative is zero.
Oh,
Yes,
Yes, that's why it is critical, right? See, and just try to remember the one variable calculus. This is just simple function in one variable f of x. Okay, then this point is critical, right? Because here f dash of x is zero. Got it?
yes.
yes, sir.
Okay. It is saying any direction. Any direction is not possible. Only one direction. Okay. Orthonormal columns for the invertible matrix can be possible, right?
Yes, sir.
Hmm. Okay. Or similarly, you can check. Uh,
Oh, 2 and 3 are only
oh, only two and
but
three. Okay, okay. Let me see again. Two and three only. Two and three.
zero nullity and non-zero determinant.
And what other option I have marked?
You said
Orthonormal columns.
orthonormal.
Orthonormal column. So okay, orthonormal columns are not possible for this. Yeah, yeah, yeah. It is saying invertible matrix only. So invertible matrix doesn't
Yes,
say that the columns would have norm one and perpendicular. It is not guaranteed. Okay, there should be orthogonal matrix. Orthogonal matrix is also invertible. Okay,
yes,
yeah. So we are saying orthogonal matrix. This is orthonormal. So this is one step further. No, 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 this is not true. 15. Okay. A fine space limit. Okay, that's it. Then next is this. If the tangent plane, how many questions are remaining? Okay, we have solved only few questions. Okay, okay, no problem.
So quite lengthy paper.
Yeah.
So this much time consuming paper will be there. Huh?
No, this kind of paper will not be there. Or maybe this is previous year question paper, so can we come? But this one is. I think we are solving slowly. That is the reason.
Yes, sir.
Yeah, that's the reason only. Yeah, we are solving slowly. Paper is not
That's the
lengthy.
reason.
Lengthy, I guess. I'm giving you time, 5 minutes or
Yes, sir.
maybe
Yeah.
more, and then I'm solving all the possibilities. So, that's why it is taking time. Okay, which one? The this one, right? What is the minimum
Yes,
sum
sir.
of the
Can.
three non-negative whose product is 27?
I think, sir, one question is like if the tangent plane exists of a function is quite.
Which one?
If the tangent. Question number 53.
So
Question number
tangent
50.
Yes,
is
yes,
Yes.
yes.
If the tangent plane exists for a function at the point, then that point. Okay. Let's see. If tangent plane exists, then what are the possibilities? Definitely that is differentiable. Okay, let's read from here. Closure with respect to no existent zero element existent as a commutative elements associated global maxima. Global maxima can be possible because tangent plane at the global maxima is possible, right?
Yes, sir.
But it is saying only possible best three. Okay, best three options. So just this is possible, but maybe this is not in best three. Saddle point, uh, tangent plane at saddle point. I think this is also possible. Saddle point neither maxima nor maxima minima, but we can make a tangent plane there. Okay, global minima similarly. Uh, Gradient global maxima minima is certainly we can make tangent plane. Gradient exists at the tangent plane. Yes, gradient exists, right? Because in finding the tangent plane, we use the gradient vector, right? So gradient exists. Directional derivative exists in any direction. So we are finding tangent plane. Uh, so directional derivative first we calculate, right? Using the gradient vector. So this is also true. Okay. So now we will remove the saddle point because this is not in the best three. Best three are these. Orthonormal columns. Okay, these are
I think sir, enter five best possible option is there.
yeah, yeah. Only best three possible options only. Okay.
Now this critical
So
point, no sir.
yeah.
For
So
tangent plane, it's saying enter five.
tangent plane says
Uh, in question, it says enter five best possible option, especially for question the tangent plane. We will done with this question.
okay, okay.
This
Five best options. Okay, here there are
yes sir.
five best options. Yeah, five best options are possible. 13, 14, 16, 17, and 19. Exactly. 13. Okay,
Gradient
gradient exists. And 14, directional derivative exists. 14 and orthonormal columns. This is 15 is
16,
also okay.
17,
Sorry,
19.
it wasn't.
16, 16, 16. Okay. First order partial derivative, yes, definitely exists because gradient vector exists. And function is differentiable, yes. That's only we are able to find the tangent plane. That means slope in that direction, which is directional derivative. 17 is
And
true.
limit, sir.
The limit will exist there. Yes.
Okay.
This question: some of the coordinates that need to be checked to identify a vector space V are
Sir,
Some
last
matrix.
problem how it is 23, sir. That
one. Last one.
question number 52.
Question number 52. It is
Yeah.
saying invertible matrix of order 3. So invertible matrix means nullity is 0 and determinant is non-zero, right? 2 and 3 option.
Okay, sir. Okay, sir.
Is there an order of priority?
Uh, Order of priority. Yes, from the top, basically. So we'll do first check first option, second, third. So which one comes first, we'll write first.
Oh.
Basically in the ascending order, right?
Yeah, ascending order. Some of the conditions that need to be checked to identify vector space V are. So when we check whether it is a vector space or not, what are the condition we check? Rank we check? No. For vector space. Nullity? No. Closure, yeah. Closure we check.
Yes, sir.
Closure with respect to addition exclusion multiplication. Fourth one. Existence of zero element, yes, we check.
Yes, sir.
Okay. Additive
Additive
inverse.
inverse.
Yes.
Yes, sir. We check that.
Commutativity
Addition,
of the addition.
yes.
Yes, sir.
Associativity.
Associative of addition.
And
Yes, sir. So,
that's it. Okay. What is this
sir,
line?
let's say in question we have say like five best option have to given, and we only put three options, then we'll get marks or not?
Actually, you have to write the. Maybe this type of question will not come. Okay, don't worry.
Okay.
What is the minimum sum of three non-negative numbers whose product is 27?
It's repeated from mass one, I think.
Yeah, this is a simple. You can write a function and maximize or minimize. What? Yeah, minimize that. Okay. Just try to do this by yourself. Simple question. Let v1, v2, v3 represent the subspace. Okay. Yeah, solve this question, all of you. I'm muting for some time. Okay, just take some time, 5 minutes. Okay, so anyone getting idea how to solve this? Anyone have any idea how to solve this question? Am I audible? Okay,
No, sir.
okay.
Yes,
I
sir.
didn't even get it.
Okay, so whoever is get have some idea, just share how to solve this. Okay, so one way I'm giving you for all of you. These are the V1 and V2. This is a good question basically. This is V2. This is V3. No, this is V2. This is V3. Okay, these are the subspaces, and the points are these on this plane. So what are the subspaces? What are the basically? So suppose we are finding A1. What is A1? What is A1?
I think it's a vector space plus. It's A1 is a fine subspace.
Okay, so the first point is this 1 1 minus 2. This one. So we can write this x plus 1, right? Plus 3 times y plus 1 and plus 4 times z minus 2 equals to 0. Is that correct? This is the A1.
Yes, sir.
Okay. So this is a one system basically, which is 2x plus 3y plus 4z equals to 2 plus 3, that is 5, and 5 minus 6 is minus 1 plus 1. This is for 1 1 actually equation. Similarly, same way you will find A2, you will find A3. Okay, so we'll have one more condition and one more condition here. Some suppose B2, this is B3, this is suppose B1. Okay, so then we will solve this and find the solution. Okay, that solution would be the intersection. Okay, So we know because there is only one point, so that is unique solution for this. So unique solution means determinant is non-zero. Okay. So this is the just system. Clearly you have solved so many times, you find the solution for this. Okay. And that solution will be some, suppose a b c, right? Just add them, or what? Yeah, this one, x1 plus 2x2 plus x3 would be the answer. Okay. uh, is the approach clear
But
to everyone?
finding that XYZ values from the A1, A2, A3,
Hmm.
XYZ.
Hmm.
Is
how
it?
to how to do that, how to do that, you are asking that?
Yes, sir.
Yeah, for that you will create this matrix. So using this, so suppose this is a1, which is 2 here, a2 and a3. So this is how we'll make this matrix. Okay. 3 4 1. Okay, one is this one. So we'll make this augmented matrix. Okay.
Okay.
So all the coefficients here, this is here b2, this is b3, and coefficients here, this is the matrix. Okay. Now we reduce it into R, R, E, F. Okay. And after reducing, we'll get suppose one. Here we get one. Here we get zero, right? Here we get zero. After reducing, okay. After reducing, here we get zero. Here we get zero. So we can directly have one solution, which is B3, and then so b3 will also be changed, right? B3 would be some suppose some b3 dash. You're getting what I'm saying? When you reduce this, you'll get a different matrix. Now it is ab, you will get, after reducing, you will get r c maybe. Okay. So in that case, one actually z value of z you will directly get. And because we have value of z, so you can find the value of y. And because we have value of z and y, you can find the value of this by taking the multiplying this, by opening this matrix. Okay. You're getting what I'm saying? I mean, this is week 2 actually, that's why I'm saying. Is that clear or not?
Yes, sir. I think it is.
Yes, sir. Yes, sir.
Yes.
Yes.
Yes, revise week 2 concepts, simply week 2 only. Okay. No, nothing more than that.
So can you
Important point.
explain how we evaluated the equation of A1?
Yeah, even actually I already find that even is this 2x 3y plus 4z equals to 1. Now similarly, that way I found a1, you can find a2, you can find a3, and then just solving three system of equations, right? A system of three equations. It will be easy. If you are not able to find, you can ask in discourse or next session. Okay, I'll solve there. Find the number of. We have to cover the concepts. Basically, revise the concepts that are important. Suppose in this week, in this I think this question, where we have to find the row echelon form and the projection. Okay, so these type of concept we are revising in this. The revision by question. Okay, we are doing in this.
Sir, excuse me, sir. Sorry.
Yeah,
In the previous question, how you got that? I don't know how to write
A1,
this. Two
A1.
x1 plus one, x plus one, y plus one, and z minus two. How?
Yeah. So affine space is of the form like suppose some vector space plus some vector a. So that vector is given here. This one for a1, and for a2 this is this, and for a3 this is this.
Okay, sir.
So
Okay, sir.
yeah.
Got it.
So this is the vector. We are just putting x1 and plus this vector first coordinate, and y plus this vector. Okay.
And A2, sir?
Thanks.
Okay.
Sir, one more doubt. That B1, sir,
Hmm.
that B1 equal to 1, you know, is it 3? Please check it.
Uh, where p1?
Here. Here. That next line.
Yeah. Next line.
That B1, 1 equal to B1, that 1 is 3, no? Just check it.
Yeah. One is b1.
No, sir, here 2 plus
Goes
3,
to
5, 5
3.
minus 8, minus
Yes,
3, no?
sir.
That 3, that one
Yeah,
value,
yeah, yeah. This is actually this constant term is actually B1.
yeah,
Which
yeah, it is 3,
at
3,
there.
no?
Yes, sir. Yes, it
Why?
is 3. You
That
wrong.
is
Correct. You can
that
correctly write it, but
two
not okay.
two
Just,
plus three. 2 plus 3 is 5, and this is 8. Okay, okay. Yes, yes, yes.
okay, sir.
This is
I
3.
think, sir, it is manageable. We can get it.
Find the number of values of A so that the system of linear equation has infinitely many solutions. Yeah, this is simple question. Just quickly solve. Okay, all of you. Is it, everyone able to got this?
Yes, sir.
Okay. This is a simple question. So I'm just explaining how can you just solve this. You have this equation x plus y minus z equals to 0. Second equation 2x plus a plus 2y plus z equals to 0. And third equation is ax plus y plus z equals to 0. Okay. Now basically you have this determinant 1, 2, a 1, a plus 2, 1, and what is minus what I've written this minus z. Okay, minus 1, 1, 1. Okay, so take the determinant and determinant of this determinant of this matrix, suppose a is 0. Okay, and calculate the value of a. Okay, very easy.
Why, sir?
Yeah,
Determinant of A is equal to 0. This means this system has
yeah.
unique
So
solution, right?
this is a homogeneous system, right? So homogeneous system means it
Okay,
already
okay,
have a
got it.
solution 0. So if a determinant is 0, that
Okay,
means
okay.
infinitely many solutions.
Mhm.
If determinant is non-zero, then only 0 is the solution. Uh, be a 3 by 3 orthogonal matrix with positive determinant. Find the following options. Is it dependent on this? No, right? Okay. Is a 3 by 3 orthogonal matrix with positive determinant. The determinant of 2a is 8. What is a? This question is looks incomplete.
A is a 3 cross 3 orthogonal matrix. So it is asking the determinant of 2A is a 8.
But what is the determinant of a?
Uh,
Orthogonal matrix, okay. Orthogonal matrix means A and A transpose A should be identity, right? And it is positive determinant. Okay, A has some positive determinant, so that we can say determinant of this. Okay, the A transpose is also A. A transpose is also A. Determinant of this is one. So we can say determinant of A square is one. Uh, A square is one. Is one. Okay, this condition is right, right? A into A transpose is equal to I identity matrix. This is the orthogonal matrix, 3 by 3 matrix. Okay, 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 okay. I got it. So A square is 1. Okay, now when we square it, so because it is a 3 by 3 matrix, so when we take the determinant, so it will be 3 to the power 3 to the power n minus 1 or
2 raised to power 3.
2 power 3.
2 power 3.
Because you multiply 2, na?
Okay, okay, 2 power 3, yes. So 2 power 3 times determinant of A is equal to, uh, am I writing it correct? Oh, sorry. What I'm doing. Identity matrix actually, when we do that, then when we, so this is identity matrix. Here it will come 2 to the power 3 times identity matrix, so which is 1. So times 1. Okay, so this will come. So basically, yeah, this will happen. So here, from here we are getting determinant of A is what I'm missing here.
The determinant of A is equal to 1. So when you multiply 2A to 2 raised to power 3 is equal to 8. So first option is quite correct.
Oh, okay, 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 okay. Got it, got it. 2 means 2 to the power 3. Yeah, I'm so sorry for this. Okay, now it is correct. That's it. A is equivalent to the identity matrix of order 3. Yeah, equivalent, yes. Equivalent it is. Why? Why equivalent? Because when we reduce to the RREF, EF, we'll have identity matrix. Why? Because they are invertible. Is that clear? Third point.
Yes,
Sir,
sir.
problem number 57.
Yeah, problem number 58. 57.
57,
Mm,
not getting that two answer.
okay. Just take the determinant of this, and determinant of this is okay,
A
okay.
square plus 4A minus 3.
Okay, then just reduce it. Okay, because A square we are getting quadratic. We can reduce some. Suppose uh,
Shall we expand as it is?
column 1 minus column 2. We are doing, and in place of column 1, we are getting 0. 2 minus this is minus A, and A minus 1. Okay, 1 A plus 2, 1 minus 1 1 1. Okay, now for creating second one, we are adding this column 2 plus column 3 and replacing at place of column 2, so which is 0 minus A minus 1. Here we get adding, so 0 adding A plus 3 and adding, so 2, which is minus 1 1 1. Okay, now we open the determinant, minus 1 times minus 2A minus minus of A plus 3 and A minus 1. Okay, no change actually we get still. So this is the determinant. This determinant is equals to 0, right? So when this is 0, uh, what we are getting?
So because A square plus 4A minus 3 is equal to 0, because it's a quadratic, so you only have two solutions, right? So The only possible value of A is equal to 2. So that's why. It
Yes,
means
yes.
two possible value of A.
Okay, okay, okay. Yeah, solve this quadratic, we will get 2. Okay, we are not getting the answer. If you are not getting 2 or getting some another answer, then that would be the answer. This is wrong. Okay.
You are getting just expanding the determinant as a determinant,
Mm-hmm.
getting a equal to a square equal to 3.
Okay.
It is
Yeah, yeah.
asking number of solution. So A square is equal to 3, so plus minus 3 is a two solution. So that's why I said 2, because it is a quadratic, so you only have a two solution. It's asking number of solution in a question. Find
Oh,
a
okay,
number of value.
okay, okay.
Oh,
Plus or
oh,
minus
oh,
3.
oh, okay, 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 okay. Okay, I think I have interpreted wrong then.
Okay.
Has infinity solution? What are the number of values of A? Yes, there are two values of A. Yeah, this is really good. Okay. Okay, this question is clear to everyone. Now solve this one. Consider the function which of the following line represents the tangent line at point 1, comma 1 in the direction of the vector 1, comma 1. Okay, this is also simple. Quickly tell me. Yeah, give me the formula for that. Tangent line, suppose L equals to f of x comma y plus fx times x minus a. Okay, this is a. Okay, a and b, x minus a plus fy times y minus b. This is the formula, right, for tangent line.
Y minus B.
Sorry, y minus b. Yes, fy of y minus b. Is that correct? Formula for tangent line.
Yes, sir.
Okay. Now tangent line at point this in the direction of this. Okay. So this direction means directional derivative, right? So what is the directional derivative at this point? Fx, Fy, which is which will come as 2x plus y and x, right? Okay. And at this point, oh sorry, this is the this is directional derivative in the direction of this. So what is the directional derivative in the direction of this? 2 plus 1, that is 3, and 1. Is that right? 3, 1. So fx is 3, this is 1. A and b are also given, which is 1, 1. So we can get the tangent line equation. Okay. And this would be the equation.
Sir, it is x comma y only given point. Why
Hmm.
how you are taking x, y, z?
Okay, then maybe formula is different. This is the another representation. This is a tangent plane, I guess, right? Formula is different for tangent line. Tangent line formula. If someone tell me, then I can say, I can tell you. Okay.
Formula for tangent line is f of a, f dash of a into f of a plus 1 is
Okay. Which one? F of. This is the formula for tangent line. F of x comma 0 plus this times x minus x naught and This, yeah, formula is correct, right? Uh, the question is representation, right? The representation. This is the definite representation, right? That is fine. We can convert this. How to do this?
They are asking for line only, right, sir? Not play.
Yeah, yeah. No, line equation of line is this, right? Because whatever formula you are telling me, give me the formula again. What are the formula? What was the formula?
That was studied in maximum for critical points if the tangent f dash of a f of a x minus
X
as a
minus
function.
x1 by L, y minus y by L.
Uh,
Okay.
that is a slope, right? That is f dash of a generally becomes.
Tangent tangents for a scalar valued multivariate function. Okay. Finding tangent hyperplane critical point. So basically in week 10 activity. Okay. Okay. Activity 2. You have to just find the formula. Okay. Yeah. So this is the formula for tangent plane. Okay. Xt is a plus t of u1. This is a parametric, basically parametric form, which we can later convert by finding the value of t. T is x minus a divided by u1, x from the second equation, y minus b divided by u2. So this is the form actually which is asked here. Okay. And so so this is actually, so xt is a plus t of u1. U1 is this unit vector on L. Okay, is that clear or not? Basically, this is the tangent line equation a comma b. So I'm writing it. Okay, where are we are solving this one, right? Yeah. First one is ab f of ab. Okay, ab is 1 1, f of ab is, what is f of ab? 2, right? So this is point plus t times this u1 u2 and fu of ab. Okay, fu is directional derivative in the direction of u. Okay, at ab. So u1 u2, even at u2 is also 1 1. Okay, this direction u1 u2. So 1 1, and directional derivative comes at this value. Directional derivative is, so gradient vector is this, right? And at this point it is 3 1. Okay, for finding the direction derivative we take the dot product with unit vector in the direction of this, or maybe this one. So we take the dot product with 1 1, and we get 3 plus 1, that is 4. Okay, is that clear?
By root 2. You are not
Yeah,
normalized it.
yeah, normalized. So by root 2.
That comes only for 4. 4 by
Yeah.
root.
Okay. No, for this we actually take the dot product in the unit direction. Okay, unit vector. Is that correct or not? Okay. And now for converting this into this coordinate form, we just take the value of t. So which is for t is x minus 1 divided by 1. Okay, second value of t is again second one y minus 1 divided by 1 z minus 2 divided by 4. Okay, but again it is root 2 is everywhere, so when we divide, we it will be 1 by root 2, 1 by root 2, 4 by root 2. Okay, 4 by root 2 will become 2 root 2. So which option is true? This first one. Is that clear,
Sir, can
everyone?
you explain that first line only 1 1 comma 1 1 2 plus t t comma 1 1 4? Yeah, that one.
Yeah, here this is the formula.
Uh,
This
what
one.
formula this one?
This is for the tangent line equation.
Oh,
Okay, this is the
so
formula.
a comma b comma f of a comma b. What is that f of a?
Yes, f is the function, a comma b is the point, and here u1 u2 is the direction, and fu is the directional derivative in the direction of a comma b.
Okay, in this problem, what is f of a comma b? How we find?
F of a comma b, this one, this point, tangent the point on the line,
Okay, okay, okay. Two, it is okay, okay,
which is this is 1 comma 1, this point u1 u2,
okay.
these are the vectors, unit vector on L. Okay,
What is fu comma a comma b? Fu directional derivative.
directional derivative, fu is the directional derivative in the direction of u.
Oh, okay, okay. Thank you, sir.
Okay, so in the direction of u, this is 1 1, we find the directional derivative which is 3 comma 1, and now we will multiply for this unit vector in the in this 1 comma 1. So unit vector, so we'll get the directional derivative which is 4. Okay, so this is how we get the tangent line, and this is the just simply form. Okay, t basically. So because all are equal, we can equalize, all are equal to t. Is that clear for everyone? Yes or no?
Yes, sir.
Okay. Okay, so we have solved how many questions? This question is remaining 60. Okay, 62, 65. Okay, 5 questions are remaining. Okay, maybe six. Okay, 60. 6 questions are remaining. I suggest you to attempt these. Okay, and in the
Yes.
whenever the next session is, I will first solve these 6 questions. Then I will solve another question paper similarly. Okay, with the concepts.
Okay,
Sir,
sir.
which term paper is this, sir?
Actually, I don't know which term paper is this. Okay, this is just a question paper. So I can give you the question paper if you want. Term I don't cannot tell you. I can give you the question paper. See here in the chat there is a link. You can click on that link and you download that question paper. Okay. Okay, fine. All of you, you can leave now. Thank you for all of you.
Thank you, sir.
Thank you, sir.
Thank
Thank
you,
you.
sir.
Thank you, sir.